Hey everyone, hopefully I left it long enough before it went live so that you don't hear like the 5 seconds of conversation and we go into Jake. Let's stay quiet until it
Just
starts.
just a few seconds of awkward silence instead.
Yeah. Uh just waiting for it to just checking the actual video on YouTube as we normally do, the weird paranoid sort of, is it working, is
Is
it
it
not?
working? Who knows?
Sweet, that sounds like it's working. Let's stay. Are you playing it as well to see if it's working, Jake?
Yeah, I thought I muted the mic, but I didn't. I just realized that I didn't.
That's the other plan B is we can just mute the mics the entire time before we hit the start button. I mean,
Yeah, this is true. But then we can hear
anyway,
each other.
hey everybody. Thanks for dropping into some awkward conversation about the logistics of starting a stream on YouTube.
Yep.
Uh, Surprisingly, this video is not about the awkwardness of starting streaming on YouTube. We're actually doing stuff. And also of note, deep apologies if you did ever watch the stream last week. It was a catastrophe. So bad that we hid it forever from public view, never to
Pretty
be seen
much.
again.
Yep.
No, I marked it as private, so it's still there. Maybe one day in the future for the lols, I go, man, this was our worst stream ever.
Yeah.
But you know, just like if you carve your name into a bullet, it's sorted because your name's on a bullet out there somewhere. If you keep your worst stream ever, you've already done your worst stream ever. Anyway, what are we doing today, Jake?
So this week this week is the start of probably a series of CTF streams on the one machine because we're doing a self-hosted VM called Pinky's Palace. Pretty old. I don't actually know how old, but it's been on VulnHub for a while. So you can freely go there, download it, run it, follow along. We're allowed to do write-ups and whatever else we want to it. And so we are going to. We did Pinky's Palace 2 as one of our first streams, I think, before we even
Yeah,
did Hack the Box. That was fun. Did a lot of,
April April 20th, 2018 was when it was released, so
yeah,
just under 2 years ago.
almost 2 years ago. So, yeah,
Hopefully, we're not spoiling anyone's fun.
nah, we shouldn't be. So, yeah, so Pinky's Palace 2 was fun. It had a good buffer overflow and a few other things in it. And so we figured we'd do this as well. Try and learn something new. And I don't know, just sharpen our skills again because it's been a while since we've done anything overly technical.
Last week, if you did end up watching, which the viewer count wasn't anywhere that high at all, uh, so I don't think anyone did, but we went through setting up because I've got VMware ESXi on a PC, so we went through spinning it up at home. But it's not that hard. You can run it in VMware or VirtualBox or on an ESXi server. It does take some massaging to do that, as we found out last week, which was half the reason why we hid it from public view, because there was like 20 minutes of how does this work?
How,
Uh,
how do we do stuff again?
yeah, so let's get into it. You might
Okay,
want to turn off the screen overlay as well, Jake.
let's get into it. So we fired up the VM. I'm using VMware. It does have a little bit of a hissy fit importing it in, but if you just keep retrying, it'll eventually work.
Do you have the JPEG overlay still going, Jake?
No,
Okay, my bad. The YouTube preview is like delayed, so it looks
it's
like
just
it
that
is, but
delayed,
it's
yeah.
fine. It's
So
fine.
when you first fire up the VM, the thing that I like about the Pinky's Palace ones is they tell you the IP address, so we don't have to go hunting for it on our network or anything like that. And this is all we've got. We've just got Pinky's Palace and a login page, which we obviously can't do anything with because we don't know anything about this box yet. So let's jump over to our attacking machine and get into it, I guess. We start off the same way that we always do with our Nmap scan, which I've already run. It's a lot quicker locally than it is on Hack the Box, so I probably didn't actually need to run it, pre-game
Yeah.
it before the stream, but I did anyway, out of habit, I guess. So we've got port 21 with FTP. We've got port 5555 SSH. and a web server on port 8000.
Sweet, pretty standard.
Pretty standard.
Since it's been a while, the Nmap we run just run some scripts against us. Is it the 10,000 most commonly used ports?
Yes. So by
Yeah.
default, it'll run. I think it's only 1,000 actually.
Oh,
Yeah,
top 1,000 ports.
1,000.
No, correct. It's just 1,000.
So it's
Yeah.
the top 1,000 ports. The SC is run safe scripts, which is just like banner grabbing and things like that that aren't intrusive. And the SV, there's a bunch of other scripts to try and get like version information. And then the ON is just to output in the Nmap format, which is this format. There's also like OG or OX for greppable or XML formats if you prefer those, but this prints nicely, so I just use the one. And then the IP address of our target.
Easy done.
Easy done. So FTP has anonymous login allowed, and our SSH we know we can't do much with, and our TCP 8000 HTTP site is running Drupal 7. So
in CTFs, normally the SSH, SSH hasn't had any major vulnerabilities for a long time. So in CTFs, don't tend to put time into trying to break SSH without actually having creds or being able to set up some creds.
I mean, if this was obviously an old version, like, I don't know, something...
I think SSH1 had problems that were bad, but SSH2, which is what all SSH is now, is not vulnerable to much.
If it looked obviously out of the ordinary in terms of its versioning or the banner that got returned, then we might look for vulnerabilities in it. But usually the point of that is in CTFs is usually like a checkpoint. So you get user, it means that you've got some SSH creds and you can just jump straight into a user shell without having to re-exploit everything along the chain, which is nice. So
Sweet.
Starting from the top, we'll look at our FTP. To do that, we go FTP 192.168.1.148, which is just my local IP. And we want to log in as anonymous with no password. Logging in, we just do a LSLA to list all the directories, and we get an error message. This error, well, it's not really an error message, but it's a message just telling us that the command was successful, but we should consider using passive. So what we're going to do you can't just swap directly into passive mode from an existing connection. So we got to exit out and reconnect, this time with the -p argument. Hey Grub, it has been a really long time. We took a break for a while, and then we took sort of Christmas, New Year, and we stopped doing Hack the Box. So,
and then last week we streamed and it was an abomination. So we were lucky no one came on.
Yeah, pretty much. But yeah, this week it's a CTF, but it's not Hack the Box. We're doing Pinky's Palace 3 for something a bit different.
So in FTP land, there's two modes, passive mode and active mode. So active mode was for, so your server might have restricted inbound ports. So you might allow port 21 and port 80 and port 443 inbound, but nothing else. And so you couldn't open up just some other port for the FTP has two channels, the command channel or control channel, which is where you send your FTP commands, and then the data channel, which comes back with things like directory listings and actual files and stuff like that. So passive mode was where so active mode was, rather than have to open up random other high ports to try and get the server to talk back on, the client would then, the server would tell the client what port the client should open up for the server to talk back to the client on. So it's like full two-way communication. Client talks to server, server initiates connection back to client. That's passive mode. In this case, for whatever reason, and we find out in a bit why passive mode's not working, so we have to use active mode, which is where
No, the
the
other way around.
server. No, 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 no. I just opened something to check. Passive mode's where the server opens up another high port. Active modes is where the server communicates back actively.
Yes.
So yes, sorry, yes. I may have had those the wrong way around a second ago. Sorry, that's what you meant. Yeah.
Yeah. So we're connecting with passive this time.
Yeah.
To get things
Passive's
sorted.
fairly common, but actives it just opens up another high port and tells the client what to talk to. So that's what we're using here, and we'll find out in a bit why.
Yes. So initially, all we see is there's a welcome file, but also slightly out of the ordinary is we've got a dot, and a dot dot dot. So we know that dot is our current directory, dot dot is the directory above, and dot 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 is not a real thing in terms of, I guess, that Linux file structure sort of thing.
Yeah.
So this is a directory that they've created on the machine, so we can just cd into that. And if we do another ls in here, we get a dot back. Looking at the permissions, it's also a directory, not a file, so we cd into there. And
the easier way to tell it's a directory is in a permissions. It's got the D at the start of permissions.
yeah, so we can see up here with our welcome file, we knew it was a file because it didn't have this D. And we've got a firewall file, so we'll also get that. And that looks like it's just about it for what we have access to on the FTP.
Yep.
So we'll quit out of here and take a look. Having a look at welcome, we've just got a nice little welcome message telling us to stay away from Metasploit and pre-made tools if we can, which is what we try and do anyway, otherwise we don't learn anything. And nice. Now let's look at the interesting one, which is the firewall file.
So most of the time, the last time I touched IP tables was a long time ago, because these days on like Debian-based systems, I don't know so much in the Red Hat world, but you've got a tool called UFW, which is an easier way to manage firewall rules. But IP tables is the way you'd manage network ACLs on a box, which it's then based on something else called IP chains, which is basically you have a packet, what processing steps do you do to it? And under the hood, this is how a lot of routers and stuff work. From memories, or at least Linux-based ones, they use IP chains to route stuff, but then there's fancy UIs that drive all of that. So the -A is defining which chain the rule should be placed in. So in this case, it's the output chain. So that's the IP chain that outbound traffic from the server goes on. So if something on the server wants to talk out to the internet or on any Linux box, it'd go through this. Then we're saying what interface as well. So at the moment, everything here is then just going what packets would this rule to apply to. So any packets from F0, so the only interface on the box.
We're assuming it's the only interface on the box.
Yeah, that are might not be, but that are TCP packets, so not UDP or any of the other packet formats you can have. And then TCP flags, that takes two arguments. The first one is which flag types does the rule apply to? So the all just means any TCP packet with any of the TCP kind of flags. So if you remember, that's like SYN, ACK, reset, and I've forgotten the rest. There's a bunch.
A bunch of others, yeah.
But the second argument then just says which flag has to be set for the rule to apply to. So only the SYN or sync flag can be set, nothing else. And then we've got the -m state is loading the state processing module for IP tables effectively. So that'll let you then make decisions based on the state of the rule. So is it new? Is it currently established? All that sort of stuff. And it only applies to new rules. And then -j means jump, because you basically tell it to jump to another IP chain. It gets a bit confusing in the background, but effectively drop is a special one that just drops the packet. Um, if you remember back to computer science or uni, Jake, do you remember the TCP flow where it's sync with the server, then the
Yep.
server sends back an
Then it
acknowledgement
acknowledges, and then
and
you send
another
a
sync?
SYNAC. Yeah.
Yeah, the SYNAC is basically the SYN and ACK flag set in the packet together, and then the final acknowledge.
Yeah.
Uh, because both the SYN and ACK flags are set, this rule doesn't apply to it. So this means this rule will just kill all attempts at creating a new outbound TCP session where something on the server is trying to initiate,
Yes.
but it will allow us to connect to the server and that middle SYN ACK step to still go through because that has both the SYN and ACK flag set. So if
Yes.
that rule was TCP flags all and then SYN, comma ACK, it would block
Everything.
inbound stuff as well.
Yeah.
Um, yeah. So that's basically all that's doing, which basically just means we can't talk out from the server using TCP.
Any new TCP connections on both IP4
Yeah.
and 6.
Things already established when the rule was created would be fine. So if there was an outbound VPN and then the rule was set up, it'd keep going unless the VPN drops and tries to reinitiate. But otherwise, nothing can start.
Yeah.
Um, which is why we can access the web server and stuff like that because they're not initiated from inside the server. So that's kind of that little bit of information on the fun that is IP tables.
That's it. So that's our FTP. We know that chances are all of our outbound connections are going to be dropped. So let's head over and check out this website. Whoops,
That maybe is the wrong one.
that was the wrong one.
Have you still got all the forwards and stuff going, or did you set them up earlier?
Apparently, no.
Yeah.
I shut down the box, but apparently shutting it down wasn't enough. They must still be running. Was it 8,000?
Yeah, it's 8,000.
Oh, proxy. Right, hang on. Let me just.
Oh, maybe it was just cached.
It could have been cached through the proxy. Okay. So, as we can see, we've got our standard looking Drupal website.
I just vanilla. I just installed Drupal and did nothing else with it.
Yep. Trying like admin, a bunch of standard credentials doesn't get us anywhere. So we remember back to our Nmap scan that sort of mentioned that it was a Drupal 7 site, and we can validate that by going to the changelog.txt. So every Drupal by default has this changelog.txt file that gets sort of put in the root directory, which if you were smart or wanted to, you really should delete this file on deployment, just so that other people can't access your...
This falls into that category, and like in pen test findings, they normally show up as either informational or low, but like version disclosures. And people always go, oh, but how bad is a version disclosure? And the answer is, well, any piece of information that might allow an attacker to figure out what is available to him in terms of attack surface should be removed.
Exactly.
So proudly, like it's the same with footers for software that proudly proclaim what subversion it is. Like, version 9.28.13 beta release candidate 15, that sort of stuff.
I was just seeing if it does like a directory listing, because I was going to say the same goes with the public directory listings.
Yeah.
But yeah, this doesn't have that enabled. So yeah, so we've got a Drupal 5 from 2018, and we know that there have been, was there 3 or 4 Drupal Geddons? I know there's been a bunch of them.
At least 3. I mean, I'm not a PHP and or Drupal user, and everywhere I work doesn't use PHP, so I wouldn't know specifically.
I'm pretty sure
one of those.
There's been a few of them. So what we want to do is figure out if this one is vulnerable to any of those. I thought that Droop Scan, which is kind of like WP Scan, which we've used in the past, I thought Droop Scan did that, but it doesn't. So
the irony of Droop Scan, if you look at its GitHub page, is it says full support for scanning WordPress and some other CMS, and there's like partial support for Drupal. I'm like, but Drupal's in the name.
But yeah,
Um,
and the good thing about like WP Scan will actually tell you if the versions are vulnerable to any known exploits and things like that. So I don't actually really see the point in Drupal Scan unless there's a flag that I'm missing. But from the GitHub, it said
yeah.
it runs all checks by default. So
When I
it's
did it, I'd forgotten what file contained the Drupal version, so changelog. So,
okay, yeah,
so I remembered, but I made the extension capitals as well. And of course, being a Linux server, it was like that doesn't match
it's all
anything.
case
And
sensitive. Yeah,
so I used DrupScan to find the version, and then I remembered what file the file name was. I had the version in it, so that was my bad.
all good.
Uh, but so effectively now we're just going to use search exploit to have a look and see what's available for Drupal.
Yep,
Um,
and we can
that
see
tool means you don't have to. If you try to go to the like exploit DB website, it's a pain in the ass compared to search exploit, which is it gives you a nice
it's yeah. I mean, it's a
um,
lot better than it was. The new exploit DB interface is quite nice in comparison. But yeah, these are essentially the same databases.
yeah.
And yeah, the CLI is a lot better than the web interface because we actually have local copies of all of these exploits. So instead of having to find the one that we want and download it through the browser, we can just go looking through this list. We were on what 7.57.
Yep.
So looking at this, we've got these
There's a bunch that are
ones
less
less
than
than
7.58,
758, which is us.
and then there's the two less than 8.3.9. Sometimes if they say they're less than something that's a version higher than your version, the vulnerability doesn't actually transfer a full version down.
Yeah, it
But in
depends
this
how
case,
big the change was between version 8
yeah.
and version 7.
Well, there was like that Apache struts vulnerability a few years back, and there was a place that their version of struts at the time was so out of date, it wasn't vulnerable to the Apache struts, like malformed header code execution vulnerability. They'd skipped it, and they'd tried celebrating, going, "We weren't vulnerable. How good are we?" And of course, all the infosec people were like, "That's not the point." um, yeah. So in our case, I think it's 4448 or 4449, one of those two.
Yeah, so looking at
That
these three that we've got two authenticated ones, which we don't have any creds for. So we're going to give this one a go, which is, if it'll highlight properly, this 4449. So because we've got this locally, what we do is search exploit -m to mirror it, and that will mirror it to our current working directory. And then we just do the code of whatever exploit it
the
is,
like
which is this
the number,
44449.
yeah, the ID.
And we see that it's copied it, and let's take a look at it. See what's
So
going on here.
one of the things to note, so there's the Python version of this and the Ruby version.
Yes.
We normally like sometimes there's a text document that outlines how the vulnerability works. Sometimes you can figure that out because the scripts got enough explanation in it, and so we can go, okay, let's build the exploit for this ourselves. This one, it turns out there's a few different endpoints depending on the specific version. So version 8 as opposed to 7. I think if some settings are enabled as well.
Yeah, it's
So
got
there's a
sort of
lot of
different settings and modules and
yeah.
things as well. So
We had planned to just write the exploit ourselves, but then we were thinking, well, we probably should go back and do it, but we'll understand what this script does at least.
yeah, so looking at the
Uh,
script, it turns out that it relies on sort of some randomly generated field values and things like that. So if we were to script it ourselves, we'd have to sort of do some scraping, and it was a lot more involved than we had the time to build ourselves, which sounds bad, but at the same time,
yeah.
we understand what's going on. We just didn't write it ourselves.
Effectively, it's a classic case of you give a payload to the correct endpoint, and that payload is just some bash commands. Because at
Yes.
some point, this thing's vulnerable to shelling out to bash on the server. And so you can get yourself some basic interaction with the server. Then the
exactly.
rest of this script is a fancy wrapper around a reverse shell it drops on the box. Not a
Yeah,
reverse shell, sorry, a web shell.
a web shell.
Uh,
Yeah, yeah.
yeah.
So we can see that it does a bunch of checks for a few different things depending on if it thinks it's version 7, version 8. Down here we've got all the sorts of different payloads depending on which version and which exploit it's trying to do. So it's quite involved in terms of figuring out specifically which form and which module on the site is the one with the vulnerability, which this handles quite nicely, which is good for us. And then I'm just trying to find the bit that actually does the sort of shelling off to the command execution stuff. I think it was down the bottom somewhere. Maybe scanning. Nope. Nope. But basically what this does, if I can find the line of code, is it takes our standard webshell.php, cmd.php file, base64s it, and then sends it to the web server with a pipe command to base64 decode it. And that's how it gets the shell. And then the rest of this is just a wrapper around that shell so that we don't have to keep sending requests in the browser, even though we can. We can also just use this script to do it all. I just can't remember what line that was on exactly. So we're going to just move on.
Yeah.
So running this, we do need to install a gem. I can't remember what it was called now because I've already installed it. Highline.
Yeah.
So when you run it the first time, it'll probably whinge, and then you just need to do gem install. Highline, and then it should work for you.
Yeah. Neither of us are Ruby experts, which is half the challenge of like reverse engineering how like sometimes you have to reverse engineer the nature of an exploit through looking at someone else's script because there isn't an explanation of how it works.
Yeah.
I mean, I suppose we could have found one if we'd Googled for the CVE, but we didn't.
True.
So half the battle is just understanding how the language works. And it's like the inline, like ternary things where it's like, put this, then colon two values. And it turns out if one of those is true, then it'll be set to a specific thing. It's all, once you understand what they are, it's fine. But it's that initial kind of, I don't know what this is.
Yeah.
And that's the verbose output.
So we run it with the verbose flag just so that we get some nicer output. So we can see that it's tried a few different things. It determines the Drupal version by looking at the change log, and then it tries a few different things, and eventually it gets to this one, which gives us some code execution and says, woohoo. So basically you can see it is sending this command out and waiting to see if it gets the expected response in terms of the payload, and if it does, that means that the exploit worked. And then further down, this is where it actually generates that cmd.php file, base64s it, and then pipes that out to base64 decode, and then dumps that out into a shell.php file, which we can now browse directly to as well.
Yeah, and they use T to do that. I think you can use output redirection as well, but T is a nice way to output stuff to a file.
Yeah.
It's also a good way to see what's happening. If you want to output something to a file and the console at the same time, T is useful. Rather than like a full redirection where you don't see anything until it's finished.
Exactly.
Right.
Yeah. So yeah, if we wanted to, we could spend our time here in the web browser as we normally would with a web shell, but this script also happens to have a nice little wrapper that pretends to be a shell when really all it's doing is a bunch of curl requests and sending the output back to us. So let's stick to that. So looking at our directory, we can see that we're in, as expected, a sort of web directory. We're in var www.html, which is something that we would sort of expect to be in. We looked at crap. I'm going to forget where it was. I think it was in sites.
Yeah, sites config.
Sites config. Is it config.php?
It's oh, maybe it's settings.php.
Default. Yeah.
Yeah.
So settings.php. And looking at this file, we do get some MySQL creds, which we tried using for code credential reuse in terms of logging in as their Drupal admin or SSH or that sort of thing. Doesn't work anywhere, so we
Yeah, there's the username and password, and then in the database itself. So we managed to write one-liner. So you can write one-liner MySQL
yes.
commands that'll use the credentials and then give it the query to run all in one. Did that and got the admin password for Drupal out, but it's salted and hashed, and you have to use the John the Ripper Jumbo version, which I've never ever managed to get working because I can't install all the dependencies.
I had to get it working on my Windows machine. Yeah, I just couldn't spend
Yeah,
the time getting it working on Kali.
yeah, and it's slow. And given if you need to use John the Ripper for something, at that point leave it as in a CTF anyway. Leave it as the last thing to do on your list while you look at all the other paths of
Exactly, yeah.
the potential investigation. So from here, then I suppose we could try and use this fake shell to do a bunch of enumeration,
Yep. But
or
in
would you
a
say we could probably set ourselves up a little bit of a better shell?
Well, exactly. So generally what you do is you get a web shell and then you want to upgrade that to a full reverse shell. So
In this case, though, remembering that firewall rule restriction, we can't use
yeah.
reverse shells.
So
But
I
luckily,
was gonna demo that, but I figured actually, you know what, we'll just talk about it. So
it,
yeah,
it
we try a
it's
reverse shell, but because of that firewall rule, any outgoing connections get blocked,
so
which is what a reverse
normally
shell is.
normally on a server, so outbound. So if you remember your TCP/IP, both server processes and client processes, so things listening and things talking outbound, both talk on ports, so inbound and outbound. So normally on networks like web servers and stuff, ephemeral high ports are open, or at least so stateful firewalls are a bit of an exception because they can tell if an outbound connection's related to an inbound connection.
Yeah,
But in older firewalls that don't do state, or like an AWS NACLs and stuff like that, you have to enable the ephemeral port range, which is like I think the top 32,000 higher 32,000 ports. So everything above 32,000 to the highest number. So processors tend to try and talk out on those by default when they're communicating out. Um, so on many corporate networks, reverse shells will work fine because all of those high ports are allowed, unless there's a stateful firewall in the way. Whereas in our case, nothing's allowed out. So we have to
yeah,
go back to another type of shell, which isn't actually all that mysterious because it's more straightforward than a reverse shell. You've just got to remember they exist, but that's a bind shell.
exactly. So with a reverse shell, what we'd normally do is set up a listener on our machine, and then on the target we would tell it, hey, go and connect out to me as the attacker. But what we want to do with a bind shell is basically the opposite. We want to tell the server, sit there and start listening, and I'll connect in to you. And that's why we use a bind shell in this case, because instead of initiating new outbound connections, we're doing inbound connections, which is perfectly fine and allowed according to the firewall rules that we know so far. So looking at the box, normally to do a bind shell, you can use netcat, but if you look, there is no netcat, there's no netcat as a thing. There is Python, Perl, Python 3, a few others. We tried a bunch of different.
So we got it working with a Python bind shell. So when we were running through this on the weekend, there was we were running through, and someone else was involved, and they got it working with the Python bind shell.
Yep.
Jake used a tool called SOCAT, which we'll go into a bit later, and I used SOCAT as well, but a different way of hooking up SOCAT that was
Yes.
less fancy than his way, which was better in every
Uh,
way.
so yeah, so SOCAT, from everything that I've read in terms of other people's description of it, it's basically Netcat on steroids. It has a lot more control over the TCP connection itself, and can go a lot lower level, I guess. So
Yeah. Apparently I'm looking at Wiki now and it's apparently based on Netcat. It can do things like SSL negotiation and stuff like that.
yes,
Um,
so I can't remember the exact link. It might have been, it was either GTFO
oh my
bins
bad.
or a different one.
CryptCat is the one that can do it. Sorry, there was an OpenSSL implementation as well, but it gives you more control over how it works and how it can talk to processes in the TCP stack.
Oh, actually, that might have been
Um,
the. This wasn't the site that I sent you, but I'm pretty sure the GTFO bins one is basically the same. Yeah. So on the server, what we want to run is this command, which will run SOCAT, tell it to listen on TCP port 1337, which is the same as us doing the -P for port 1337 in Netcat. Let me just bring up my notes on what all of these arguments mean. So the reuse ADDR allows other sockets to bind to this address. So it doesn't create an exclusive lock on this port or anything like that. So you know how sometimes if you're running Netcat or you're running Burp or something on port 8080
what
already.
was it? What was it back in the day? If you're running Skype, you couldn't also run like a local WAMP. Remember that WAMP server
Yes.
thing where you'd
Yeah,
run Windows
exactly.
Apache on Windows,
Yeah,
and Apache wouldn't start because Skype also hogged port 80.
because it
So
took over that port and wouldn't let anything
yeah,
else use it. So the reuse address basically says if anything else wants to use this port, let them. And the fork argument turns this into a stable shell for us because it creates a connection in a child process. So it'll run SOCAT not in our current process, which is our crappy web shell with a timeout.
PHP file that times out after 30 seconds.
Yes. So as we know, web requests usually have a timeout. In this case, it's about 30 seconds. So adding this fork, forks this off into a child process, meaning that it's always listening on port 1337.
I had to use NoHup because I didn't know any of the arguments to this. I was just YOLOing it. So I used NoHup, which is a Linux utility for effectively disconnecting a process from the shell it was started in.
Yeah.
So that when you disconnect, there's something within the Linux shell or the shell which then sends a thing to all processes running under that shell or under that TTY called the hang up signal saying users hung up, turn yourself off.
Yep.
No hub just blocks that so that your thing keeps running, but it was ghetto.
Yeah.
This
And
is a
that's
bit
what
negative.
this SIGINT is. So that's a signal interrupt, which is like when you press Control C or do something like
Yeah.
that to kill the process. So yeah, this exec section of arguments is sort of what script or what things do you want SOCAT to run or this connection to run. So this could literally be a script that says, echo hello to temp.txt or something. It could be spin up SSH if we thought that our user had permissions to run SSH or other commands. We could tell SOCAT to directly run those and just pump them out onto a file or onto this sort of connection if we had a pre-existing connection. But in this case, all we're telling it to do is run bash and handle sort of the standard in, standard error, all of that stuff, so that when we get our reverse shell, what this is our bind shell, sorry. What this is essentially doing is creating, you know how usually we create our reverse shell and then we need to upgrade it so that we can pass our control C's and all of that kind of thing and press up and down in the terminal and do all that stuff. That's pretty much what this section of this command is doing. And I just copy pasted it directly from, it wasn't GTFO bins, but GTFO bins uses the exact same command. So it's a fairly common way of doing a bind shell in SOCAT.
It'll pass those through rather than trying to handle it themselves.
Exactly.
Which means requisitely, though, that doesn't magically mean that all works, because on the client side, then you need to run SOCAT so that it too will ignore that and pass it through so that you don't kill SOCAT locally when you control C, or
exactly
netcat. It's the same problem in netcat. You can tell netcat to not handle all that stuff as well, or you tell the TTY not to handle all that stuff, and then you spin up netcat, and then it all works.
Exactly.
But you end up with a balked shell if it doesn't work. You got to like kill it and start again.
So with something like if we were using the Python bind shell, we might use netcat to connect to that, and it would work perfectly fine. But in this case, like you said, we can use netcat, but it will be a bit balked. Whereas if we use SOCAT and send it the expected sort of arguments to, so you know how when we do our shell upgrade, we send it TTY raw echo, and that's our way of saying pass through all of these like SIGINTs and hotkeys and whatever else. And this is sort of the SOCAT way of doing that, so that when we get a shell, it's nice and clean and not balked.
Which is why when I tried to use this to connect to the SOCAT, when I tried to use that to connect to a SOCAT reverse shell, it appears to hang because it'll sit there trying to connect to something that's not listening, but it now ignores Control C, so you can't kill it. So you kind of have to just close. Luckily, tabbed shells, so you just close it and it's all good. Exactly. But you're in.
Yeah, so you can see here that we've got a full shell. I could probably cat. What's a file that would be here? Index. We get the tab autocomplete. I can Control C and it doesn't kill my shell. So, and that's what all of these extra arguments are doing for us. Which, is like you said, it almost makes it better than a reverse shell in a lot of ways.
Unfortunately, SOCAT doesn't come on too many Linux distributions. Netcat's kind of common, but SOCAT's a special version that's...
It's not normally on there by default, no.
No. Useful to put on there, I suppose.
Yes.
You could probably just rename it Netcat as well, and no one would suspect.
True. Yeah, I guess in terms of a way of gaining persistence or some sort of like post-exploit step could be to alias it in. Yeah.
Anyway, so now that we've got a better shell, we should probably do some enumeration.
Yeah, so we do a bunch of enumeration. We see that we can't... let's see what users are on the box. We've got a PinkSec management, and
we've got root. Pinky as well, up a bit higher.
There's also Pinky, yeah.
And we're www
and we are www data, which can't do anything too useful. We're not in any fun groups to do anything useful. We can't access anyone's home directories. Looking at our...
There's no useful sticky bits either.
No.
When we checked.
Yeah, so we looked for sticky bits, and there was nothing sort of out of the ordinary there. What we've got on here is a couple of them are... Actually, none of them are me, so that's fine. It did wipe all of my... So that web thing earlier must have been cached because it did wipe all of my extra things from the other day.
Yeah.
So the only thing on here that we've done is this one here, and the rest are pre-existing on the box. I think, do we say before that we got a UDP shell working as well? Did you get a UDP shell working as well? Because I think the IP tables is only running on TCP, so chances are we could do a UDP reverse shell if that was... If
you really wanted a reverse shell. I mean, a forward shell's fine. Or bind shell's fine.
there's nothing wrong with the bind shell that we've got, so we're just going to stick to that.
From an IDP, sorry, not IDP, from an IDS perspective, or from like a host-based intrusion detection, processors listening on ports might alert, whereas processors sending out, like connecting out on ports, is fine. So there may be some reasons where you might want to try and get in a CTF or in a pen test to get a UDP reverse shell working, because the TCP shells
I think that's
are
generally
bind.
why
Yeah,
why we sort of use a reverse shell over a bind shell, is because,
yeah.
as you can see, this is sort of permanently saying, hey, this is just sitting here listening for a connection. And yeah, IDS systems and things like that will probably pick it up. Anyway, looking at the rest of it, so 8000 we know about, 555 we know about, 3306 we didn't know about, 80 we didn't know about. They're both listening locally only, so
Locally.
that's why.
Although when we ran through it, 3306 is the local MySQL database for Drupal that has nothing really that useful
Yes,
in it.
exactly. So 3306 is the default MySQL port. We can connect to that because we've got creds.
Actually, technically, it's MariaDB if I'm going to be super smarmy about it. It's
But
practically MySQL.
we won't bother because there's nothing there. Port 80 is interesting. So there's some sort of web server that's listening local only based on the port number. That's what we can assume. And 65334, we don't know what that could be. And we don't know what process is running those because we don't have permissions to. That's sort of the assumption here, is generally if you can read what program is the one that's listening on those ports, like we can see here, it means that we would have permission to execute and potentially play with those apps. And that's why we sort of looked for sticky bits and stuff.
If you do a
PS.
PS AUX, you find that there's Apache 2, a couple of instances of Apache 2 on the box running.
Yeah, so looking at this,
So,
we've got, where is it? Apache 2 running
which
under PinkSec.
the next step would be to look at the config, which we can read for Apache,
Yes.
just to see what might be there, where they are on the box. Although I think they show up inside that user's fault, like home directory, so we can't actually touch them.
No,
yet.
so yeah, we looked at the Apache config files to find where the web root is, because the web root for Nginx is var www.html, but the web root for the Apache 2 stuff is in, I think they're in PinkSec's home directory, so we can't read or see what's going on there either. What we can do locally, if we cd to temp, we can wget this localhost file and just see what's there. If I can spell. And what we get is some sort of custom PinkSec homepage with a login. Well, it looks like it'll be a login form. Now, running locally like this and using wget is not going to be very useful to us. So I think what this talks about, no, this one doesn't talk about it.
No, it was another one that talks about how to
article,
forward.
which will be linked in our write-up, includes a port forward. Oh no, let's not watch a YouTube video on it.
I've got the code.
I've got the code,
somewhere.
but I don't have the link to the page that explains it. So basically, in the same way that if we had SSH, we would create an SSH tunnel. What we're doing here is creating the SOCAT equivalent of sort of an SSH tunnel.
I said code, I meant command.
So again, we're telling SOCAT to listen, this time on port 8001 with the same arguments, reuse that address and fork it out to a child process. And adding the TCP localhost 80 is telling it to forward anything that we get on port 8001 to the local port 80, which is the similar sort of way that the SSH tunnels work.
and then tunnel back.
and
That
tunnel
could
back.
also
Yeah,
be a remote host only accessible from that server. So
exactly. Yeah.
effectively, it becomes a TCP proxy.
Yes.
Um,
So what that means now is if we browse to here on port 8001, we get the website that's hosted on port 80 that's only available locally. Because as far as the Apache web server is concerned, the request is coming from this local SOCAT. Kind of. That might not
yeah,
have been the best
but
way
it's
to
coming.
explain that.
It's effectively coming from another process on the box. So
Effectively, it's coming from a local process rather than from a remote
it's
connection.
it's
Yeah.
similar to the forwarding we've done in SSH.
Yes.
Yeah,
So now
basically the same thing. Yeah,
what I'm going to do here as well, I think I did this in our web shell because this is running now, it's basically taking
yeah.
control of our shell. So
I
I'll do
used
the other one here.
I used NoHup again to keep that shell going without nuking it.
Yeah. So this time on
And
8000 and
yeah,
oh yeah.
all good. Never
Okay.
mind. Keep going.
This time on 8002, we're going to tell it to listen on this other port that we don't know what it is, called 65334, which is... So the beauty of this one is it just times out after 30 seconds. So I could have rerun, the same commands twice and not lost my full shell, but that doesn't matter. We're kind of done with that for now anyway. So that's run. So now we can also access port 8002 and see if anything interesting was there. And we just get a standard. So it is a web page. And this time it's just saying database under development. I'm pretty sure now, I didn't actually do this last time, but if we nmapped again, those new ports should show up this time. And if there's any interesting banners and stuff, we should get some useful info from that. I should have actually changed it to just do the ports 8001 and 2. So yeah, we can see here this time that they are both running HTTP Apache sites. So that's how we can sort of determine that we can just browse through a browser. So if this 65334 was an internal FTP or something else, then we could just have to use, an FTP client or whatever else we wanted to use rather than the browser. But we just kind of got lucky that they're both websites.
Well, and this is why if you're ever helping people design systems, understanding that there are ways for, I would always recommend binding processes like the network side of processes to local addresses if they should only be listened to. So like a database, you'd bind it to the local address.
Yeah,
because it turns out the TCP stack is a really easy way to do inter-process communication on a server or on a box. That it is understanding that this can still be accessible if there are other. So either if Netcat's on the box and someone can at least run that, and because any user can talk to the entire port range, it's not, you only need to be root to expose something on anything less than port 1024, I think, or 1023, one of those two. But you can listen to anything. So if you can get on the box and then use something like Nmap to route something through, or they've got SSH access and they can SSH forward, then that thing's not as secure as you thought. It can be exposed outside the network.
As you thought. Yeah, exactly.
Yeah. So it's just bearing that in mind. Again, not a reason to not bind things to local addresses. It's just the local host or 127.0.0.1. It's just understanding that
is not a protection in itself. Yeah.
Yeah. Yeah. Defense in depth. So hopefully you think of a ton of other things. Because plenty of stuff, again, uses the TCP stack for internal process communication. And that's where we're going to leave things this week.
Yeah, so this is sort of a good logical stopping point in terms of the CTF. So we've gained access to a whole new site and a whole new application to potentially start from scratch and exploit as if it's a brand new application. So we're going to stop there and do that as part 2.
And in theory, it's two because there's that database one as well.
Yes. So
Um,
we've got
so
this website and we've got this random database site. So they are, yeah, two brand new applications that we haven't seen before. So we need to run through the whole process, re-enumerate, and figure out if any of these have potential vulnerabilities for us to exploit. So yeah, that's why this is a logical stopping point for part
stopping
one,
point.
and we'll go from here next week, probably in part two.
Have a good one, guys.
Yeah,
Thanks for
thanks
watching.
thanks for coming along. Hopefully you learned something new. We definitely learned a lot about SOCAT and the sort of stack around that doing
A
this.
lot of
So
this, a lot of this stuff is its specifics as to how specific tools work.
yes, yeah,
So knowing what these network utilities do is one thing, but knowing how a specific one works and what the power of it is, because Netcat you can't tell it to just fork off,
no,
fork
no,
off, fork off like SOCAT can. So you would have to find a way to make it persistent. Again, I use NoHup is the simple way I know. If
yeah.
screens on the box, you can use screen.
If you have command execution, like full command execution on the box, you could do the and like
That
the ampersand,
so
which
that
will kind of child process it.
that only so you have to do that, and then you have to disown the
It's
process.
not as good.
Uh,
Yeah, yeah,
yeah, you well, the no hub things are easy way to do it, and
yes,
it's normally on everything. Whereas the ampersand basically tells it to not lock the terminal, but it also means the standard out and standard error will keep popping up while you're trying to use
yeah,
the terminal.
exactly. Yeah,
So
yeah. It's not
you
as
then
good
want
as
to
the
set
no
that
hub, where the no hub
dev
will
null.
redirect all of that stuff onto a file. I think on the local machine.
Yeah.
Yeah,
Although you've got to be careful with that because you can, if your process is particularly noisy, take up your entire file system with its output,
all of its
which
output.
I've
Yeah,
had happen before. Anyway, cheers, guys. Have a good
yeah.
one.
Thanks for coming along. We'll see you again next week.
Bye.
Bye.